This is our second video in the important questions and concept series. We have earlier done a video on important questions for CAT in the topic of geometry, and we have also explained all the formulas which are important for geometry. That is there in the earlier video. Definitely check it out. Today we'll be discussing time, speed, distance and work. This is a topic in arithmetic which is actually very important for CAT. Why is this important for CAT? Because if you think about it, the questions that are asked from time, speed and distance, they are definitely on the easier side. And every year at least 2 to 3 questions will be asked from this topic. And you should target getting all of them correct because the accuracy can be really high in this particular topic. And this is definitely, as I just said, one of the very important topics. Let us look at all the formulas. The first formula, which is the basic formula in time, speed and distance, is that distance is speed into time. So if you are told that there is a person who is traveling at 10 kilometers per hour and he travels for 2 hours, then the total distance that he has traveled will be 10 into 2, which is 20 kilometers. Similarly, if you are given the distance and the speed, you are told that he has traveled 20 kilometers in 2 hours. Then you can get the speed by dividing the distance and the time taken. Similarly, the time taken can be found out by dividing the distance with the speed. These are simple basic formulas which will be definitely the stepping stone for solving more difficult problems. Another important thing that you should notice is in some of the questions, the units might be different. You might be told that one person is traveling at 10 meters per second and another person is traveling at say 20 kilometers per hour. Who is traveling faster? To do these kind of things, you should definitely get the units to be the same. And in order to convert meter per second into kilometers per hour, you should multiply the number with 3.6. 3.6 is 18 by 5. So 10 meter per second, for example, will be equal to 36 kilometers per hour. Many people actually ask us where they can take good mocks for CAT. If you are looking for free mocks with video solutions for CAT, definitely check out the free CAT mocks of Cracku. We are providing 3 free CAT mocks. Let us look at the next slide. If you are told that the ratio of the speeds of A and B is A is to B, then the ratio of the time taken by them to cover the same distance is 1 by A is to 1 by B. And the distance traveled by them in equal time is A is to B. Just to give you an example, suppose you are told that the speeds of A and B are in the ratio of 2 is to 3. This is the ratio of the speeds of A and B. Now, what is the ratio of the time they take to travel say 60 kilometers? The distance is the same. Then the ratio of the times taken will be 1 by 2 is to 1 by 3. Which is equal to 3 is to 2. And if you are told that both of them have traveled for the same time, that is both of them have traveled for 1 hour, then the ratio of the distance traveled by them in this 1 hour will be 2 is to 3. Let us look at the next formula. The average speed is the total distance traveled by time taken. This is again quite often asked. Many times you are told that a person is traveling by bus for 2 hours. The speed of the bus is 20 kilometers per hour. And he traveled for 3 hours after that in a car and the speed of the car is say 60 kilometers per hour. Then what is his average speed? To do that, you have to first calculate the total distance he traveled. In the bus, he has traveled 2 hours at 20 kilometers per hour. So he traveled 40 kilometers. And in the car, he traveled a total of 3 into 60, that is 180 kilometers. So the total distance he traveled is 40 plus 180, which is 220 kilometers. And the total time he has taken is 2 hours plus 3 hours, which is 5 hours. So his overall average speed is 220 divided by 5, which is 44 kilometers per hour. This is exactly what is expressed when you are told that a part of the journey is traveled at S1 kilometers per hour for T1 hours. And S2 kilometers per hour for T2 hours. So the total distance he traveled is S1 T1 plus S2 T2 and the total time he traveled is T1 plus T2. So the average speed will be S1 T1 plus S2 T2 divided by T1 plus T2. Let us look at the next formula. Now instead, if you are told that he has traveled D1 kilometers at S1 and D2 kilometers at S2. So now we are not told the time at which he traveled, we are told the distance he traveled using the two modes of transport. This is basically telling you that using a bus he has traveled 40 kilometers at 20 kilometers per hour, and using a car he traveled 180 kilometers at 60 kilometers per hour. Now you are given the distance, so you can easily calculate the total distance. That is 40 plus 180, this is 220 kilometers. And you will use both of them to calculate the individual times and then sum it up. For example, the individual time he has traveled by bus will be 40 divided by 20, which is 2, plus 180 divided by 60, which is 3. Again the answer will be 220 by 5, which is 44 kilometers per hour. Or D1 plus D2 is the total distance traveled, and the denominator, which is the total time taken, will be D1 by S1 plus D2 by S2. Let us now look at the next slide. In this tip, we are told that if a journey is traveled at different speeds and the distance covered in each stage is constant, then the average speed is the harmonic mean of different speeds. This is just an extension of the earlier slide, where we are told that if the distance is constant for all, then the total distance traveled will be D plus D. Say there are three modes of transport, and the total time taken will be divided by D by S1 plus D by S2 plus D by S3. Because in each mode of transport he has traveled the distance of D, and the speed of the first mode of transport is S1, so the time taken in that mode of transport is D by S1. In the second mode of transport it is D by S2. In the third mode of transport it is D by S3. So the overall time taken, if you are cancelling D, the average speed in the numerator and denominator will be 3 divided by 1 by S1 plus 1 by S2 plus 1 by S3. This is basically the harmonic mean of S1, S2 and S3. This is again just an extension. If the modes of transport are just 2, then it will be 2 xy by x plus y. This is the harmonic mean of x and y. Let us now look at the next slide. Also, if you are looking to download the important formulas for all the topics, we have the link. You can check this out. Just Google search Cracku CAT formulas. So in addition to time, speed and distance that we are checking today, you can get the formula PDFs and the questions PDFs, like for other topics like say geometry, logarithms, all of them. Just Google search Cracku CAT formulas, then you will get that page. Let us look at the next slide. If the journey is traveled in different speeds, earlier the distance was the same. Now if the time is the same, so we traveled for 1 hour by bus at 20 kilometers per hour, 1 hour by car at 60 kilometers per hour, and 1 hour by say horse at 80 kilometers per hour. If the distance is the same, it is harmonic mean. If the time is the same, then it is the arithmetic mean. Suppose he traveled for 1 hour in each of these three modes of transport, then the total distance he traveled by bus is 20 into 1, which is 20 kilometers per hour, plus 60 into 1, which is 60 kilometers, plus 80 into 1, which is 80 kilometers, divided by, because he traveled for 1 hour each, divided by 3. This will be equal to 160 by 3, which is the arithmetic mean of 20, 60 and 80. Now if there are only two modes of transport, the arithmetic mean will be x plus y by 2. Let us now look at the next slide. Now this slide, again we are just discussing the same thing. If the distance is the same, then the average speed will be the harmonic mean. If the time is the same, then the average speed will be the arithmetic mean of the different speeds. Let us look at the next slide. Clocks. Clocks also is a very important topic. One of the things that you should remember is that in a well-functioning clock, which doesn't lose time, if you have the minutes hand and you have the hours hand, the angle covered by hours hand in 1 hour, the hours hand moves 30 degrees and the minutes hand moves 360 degrees. Because in 1 hour, the hours hand will move exactly 1/12 of the entire circle. The entire circle has 360 degrees. So the angle that it travels in 1 hour will be 360 by 12, that is 30 degrees. The minute's hand will cover the entire circle. So the angle it covers is 360 degrees. This is something that you should remember. This is the distance or the angle that each of the hands of the clock covers in 1 hour. Now both the hands will meet exactly after 7:20 by 11 minutes. How do you know that? It is very easy to figure it out. Now suppose both of them met at say 12 o'clock. Both of them are facing the upward direction. Now initially the minute's hand will continue to move forward faster as compared to the hour's hand. Let us assume that they meet again after say x minutes. So in this x minutes, what is the distance or what is the angle covered by the minute's hand? The angle covered by the minute's hand will be x into 360 degrees divided by 60. Because it covers 360 degrees in 1 hour. So in 1 minute, it is going to cover 6 degrees. In x minutes, it is going to cover 6x degrees. And what is the distance that it is going to move? What is the distance that the hour's hand is going to move in 1 minute? In 1 hour, it travels 30 degrees. So in 1 minute, it is going to move only half a degree. And in x minutes, it is going to move x by 2. 6x minus x by 2 has to equal 360 degrees. Because initially both of them were together. After the minute's hand travels 360 degrees more than that of the hour's hand, they again meet together. So this would imply that the value of x has to be 720 divided by 11. In circular tracks, that is if there are two people who are running around a circle, if both of them are starting at the same point, and if the ratio of their speeds is a and b, and if they are running in opposite directions. Let us assume that the ratio of their speeds is a is to b such that a and b are co-prime. They don't have any common factor. If they are running in opposite directions, then the number of points at which they meet will be a plus b. And if they are running in the same direction, the number of points at which they meet will be a minus b. If a is greater than b, otherwise it will be b minus a. That is just to give you an example, if there are two people and if their speeds are say 6 kilometers per hour and 4 kilometers per hour. If they are running in opposite directions, the number of points at which they meet will not be equal to 6 plus 4. If you write 6 plus 4, it is wrong. Because 6 and 4 are not co-prime. They have a common factor which is 2. So if the ratio is 6:4, we have to first calculate it in the lowest possible form, which is equal to 3:2. So the number of points at which they meet will be 3 plus 2, which is equal to 5. If they are running in the same direction, the number of points at which they meet will be 3 minus 2, which is equal to 1. Let us now look at the next slide. In circular tracks, if the perimeter or the circumference of the circle is say L, and if they are running in opposite directions and if the speeds are m and n, then they meet for the first time at L divided by m plus n, and if they are moving in the same direction, then they meet after L divided by m minus n if m is greater than n or n minus m. In this tip, suppose we have two people and they are moving towards each other. Suppose one person is moving from A towards B and another person is moving from B towards A. Suppose they meet at a point over here, say C. A is going towards, let this guy be P, P is going from A to B and Q is going from B to A. Now suppose P takes x hours to go from C to B. After they met each other at C, suppose P is taking x hours. And after they meet at C, suppose Q is taking y hours. Then the time that they have actually taken to reach C, that is the time P has taken to reach C, which will equal the time that Q has taken to reach C, because both of them are meeting at C, the time will be equal to square root of x into y. This is important because this will help us in calculating the ratio of the speeds of P and Q. Suppose for example that A and B are going towards each other, and suppose after meeting each other, A takes 4 hours to go to B. That is P, the first guy, after reaching C, he is taking 4 hours. And the second guy, Q, after reaching C and after he leaves C, he is taking 9 hours to go to A. Then the time that both of them have taken to actually reach C in the first place, that time is equal to square root of 4 into 9, which is equal to square root of 36, which is equal to 6 hours. You can also calculate the ratio of their speeds. The ratio of the speed of P and Q will be in the inverse ratio of the square root of the time that they have taken afterwards. That is, in this case, if P has taken 4 hours to reach B after they met, and if Q has taken 9 hours, then the ratio of the speed of P to Q will be square root of 9 divided by 4, which is equal to 3 by 2. This is the same thing that we discussed. After they meet, if the first guy has taken T1 hours and if the second guy has taken T2 hours, then the ratio of their speeds will be square root of T2 divided by T1. And the time they have taken to meet each other in the first place, that will be equal to square root of T1 into T2. This we discussed in the earlier slide. Now suppose you have trains. There are two trains which are passing each other. Suppose the length of the two trains are L1 and L2. And suppose they are going at speeds of S1 and S2. And if they are going in opposite directions, then their relative speed will be equal to S1 plus S2. And the total distance that they have to travel will be L1 plus L2. So the time that they take to cross each other will be L1 plus L2 divided by S1 plus S2. If they are going in the same direction, then their speed will be S1, the relative speed will be S1 minus S2 if S1 is greater than S2, otherwise it will be S2 minus S1, and the distance that they have to cover is the same, it is L1 plus L2. Therefore the time that they take will be L1 plus L2 divided by modulus of S1 minus S2. Let us now look at the next slide. This involves work. This says that if X can do a piece of work in n days, then in one day, the fraction of work that X is doing is 1 by n. Similarly, if X can do a work in X days and Y can do a work in Y days, if both of them are working together, the number of days that they take to finish the job will be X into Y divided by X plus Y. That is because in one day, the fraction of work done by X is 1 by X. The fraction of work done by Y is 1 by Y. So in one day, the fraction of the work that they have completed will be 1 by X plus 1 by Y, which is equal to X plus Y divided by XY. This is the fraction of the work that they have finished. That is, you can say that suppose this equals 1 by 3. We are saying that they have finished 1/3 of the work in one day. So the number of days that they take will be the reciprocal of this, which is X into Y divided by X plus Y. Similarly, if you are told that if M1 people work for H1 hours per day and they work for D1 days and they completed W1 work, what this would imply is that the total man hours that were utilized will be M1 into H1 into D1. This is proportional to the work done. If this many man hours was inputted into getting a job done, this will be the same as M2 into H2 into D2, which will be the man hours that another job has taken. So the work done will be in proportion to the amount of man hours that was inputted. Another important concept is that of boats and streams. If there is a boat which travels at a speed of B in still water, that is when water is not moving, and if the speed of the water is say W, then when it is going downstream, that is when it is going along with the water, the speed of the boat with respect to the ground will be B plus W. But when it is going upstream, that is when it is going against water, the speed of the boat will be B minus W. Another important aspect is that of inlet pipe and outlet pipe. This is very similar to work done by men or women. If a pipe can fill a tank in X hours, in 1 hour it is going to fill 1 by X. And if a pipe can empty a tank in Y hours, in 1 hour the fraction that it empties will be 1 by Y. And therefore the amount or the fraction that it fills in 1 hour will be, with if both of them are open, will be 1 by X minus 1 by Y. In general, for these kind of questions, what I find it to be easy is assuming that the volume of the tank is the LCM of X and Y. I'll make it clearer with an example. Suppose there is an inlet pipe which fills the tank in say 10 hours. And there is an outlet pipe which empties the tank in say 15 hours. What is the LCM of 10 and 15? The LCM of 10 and 15 is 30. So what I would assume is that the volume of the tank is say 30 liters. The inlet pipe takes 10 hours to fill 30 liters. So in 1 hour it is going to fill 3 liters. The outlet pipe takes 15 hours to empty 30 liters. So in 1 hour it is going to empty 2 liters. So if both of them are open at the same time, the amount of water that is filled will be 3 minus 2, that is 1 liter. And the time taken to fill will be 30 liters, which is the total volume, divided by 1 liter, which is equal to 30 hours. This way there is no confusion and the calculations become very easy. Now the thing that you should remember is that solving questions will consume a lot of time. But it is very, very important for you to solve questions, because if you solve questions only, then you will be confident. We have given a bunch of questions at the end of this PDF. We'll go through them now so that you can understand how to actually approach these kind of questions. Every question has a video solution, and I would recommend you to watch the video solution if you are not able to get the question, because then you will understand that solving these questions is not very difficult. Your confidence also will be impacted, your confidence also will be boosted. Let us now look at the questions. Now that we have gone through all the important concepts and the important formulas for time, speed and distance, let us look at some of the questions. Before we go to the questions, if you are looking for any guidance from IIM alumni with respect to how to prepare for CAT, send us a WhatsApp, just WhatsApp CAT to this particular number. This is our support number and we will get in touch with you. In addition to that, all of these questions that you are going to see, all of them are part of the CAT previous year's papers. So if you are looking for more questions from this topic or from any topic, definitely download the CAT previous papers. Just Google search Cracku CAT previous papers. All the previous year's papers are available in PDF format along with video solutions on our website. Definitely Google search Cracku CAT previous papers, and then you will get that site and you can check them out. In this PDF, we have 68 questions from time, speed, distance and work, all of them with video solutions. The way to go about it is have a pen and a paper, download this PDF, look at the first question and try to answer it. In this case, for example, you are told that Karan and Arjun are participating in a 100-meter race. So this is a time, speed and distance question. Try to answer it to the best of your ability. If you are able to answer it, that is good. If you are not able to answer it, then just click on this button over here. If you click on this button, you will be redirected to our website, which has the same question, Karan, Arjun, the race, and then you will be seeing the video solution. The video solution is over here. If you just click on it, you are going to get a video solution where I explain the best way in which you can answer this question. So this is a very useful PDF. It has 68 such questions. Go through each one of them. Try to attempt them to the best of your ability. If you're not able to attempt them, or even if you think that you have solved it in a very long manner, you should definitely check out the video solutions for each one of them. All of these questions have detailed video solutions. For example, if you're looking at the second question, you have to click on this button over here and you will get the video solution. If you like this video, if you like the effort that we are putting in, please do comment below the video. Please do share this video with your friends and prepare well for CAT.